Hi there! This video series is to display my problem-solving and learning abilities. I hope to show that I can solve any programming problem, regardless of whether I already have expertise in the language at hand. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. For now, I am learning Python. I have no professional experience or formal training in the language, and have only been learning it since mid-January. While I'm picking up fairly quickly, I cannot claim any real expertise. Today, I am going to show my approach to solving the third Project Euler problem. As you can see, again, I've already solved this, but I'll be starting fresh and talking through my thought process, so hopefully it's still somewhat educational. I will link to both Project Euler and my repository in the description. Let's dive in. Okay, problem 3 is largest prime factor. It describes prime factors of this number, and then asks what is the largest prime factor of this giant number, which I'm not going to read out loud. So first, let's go ahead and copy our problem statement, which unfortunately this is an image, so we'll have to be a little bit back and forth here. 6008514. Create our new Python script for this. We definitely want it to be a comment. 75143. And then, of course, since we do already have the answer, and I don't want to keep jumping back and forth, let's do that. So, of course, a naive approach could be to just go through every number lower than this one, check whether it is a factor, and check whether it is prime. And I believe when I very first solved this problem, that is the approach that I went to, but today I would like to try something a little bit more sophisticated. So if we think about math and what a factor is, the largest factor of a number is the square root of that number. So for our purposes, we really only need to go from 1 to square root. And honestly, we don't even need to start with 1, or with 2 in this case, but let's go ahead and do that and see where we go. So first, let's define a method to check whether a number is prime. Python convention is all lowercase with the underscores. So is this number prime? Let's say it takes in a number we'll call possible prime. And this is going to return true or false. So here for, let's do I in range 1. Okay, I forget what it is for the square root here. So actually, let's just look that up. Python find square root. Exponentation. I'm gonna pretend I pronounced that right. 0.5, so So for every number in this range, we want to check, and honestly, instead of 1, let's just go ahead and start with 2. Yeah, start with 2. And we really want this to round to an int, which I believe this int method will let us do. We'll find out. If possible prime mod I equals 0, so if possible prime can be evenly divided by this number, then that means that is a factor of this number. So return false. If we go through all of those possible factors and none of them have been found, then we return true because it is prime. I added some Java/JavaScript notation in here. Let's not have that syntax. Let's have the right Python syntax. And then actually let's define is factor as well, just to save ourselves some headache later. And this time we'll do possible factor and num. So I think we would just need to return num mod possible factor equals 0. So if it is equal to 0, then it is a factor. Otherwise, it isn't. And obviously, we can already take and refactor here a little bit. Put this up here. And instead of this check, we can just say if is factor and pass in I, comma, possible prime. Okay, so now let's do our number equals this 600851475143. And we want to find the largest prime factor. So, for in range, okay. Let's go ahead and start with 2. And then number, or actually int number 0.5. So for each of these numbers, alright, let's have another thing here. We want largest prime. If is factor in number and is prime in. So if it is a factor and it is a prime number, then we want the largest prime to become n. And that should work because we are going upwards. So anytime we have a new possible number, it's going to, by definition, be bigger than the last one. Otherwise, we'd want to do another if check, of course. So let's go ahead and run this as is. Okay, so we actually did get the correct answer here. You can see it's the 6557 that Project Euler confirmed was correct when I did this back in January. And looking at this, there is some improvement that could be done. That I can already see, at least. We could have, for instance, a list of different primes that we then kept, and every time is prime was called, we would refer to that list and only look for those numbers instead of going through the entire range. Obviously, we meet Project Euler's under a minute runtime recommendations, but that is a little bit of a refactor that we could do. So let's go ahead and see what that might look like. And I'm going to go ahead and make this a global variable called primes, and that equals an empty list. And here, every time we find something as a prime, we're going to call primes.append possible prime. And now, instead of all of these numbers, but first, is there a number that is divisible by a factor that isn't a prime, but not divisible by a prime? No, by definition, every number that isn't a prime is divisible by a prime number. So, all even numbers are divisible by 2, the prime number. Every third odd number is divisible by 3 or so. Not every third, but, you know. So let's see. So instead of doing for I in range here, we can do for I in primes. And say if this number is a factor for the possible prime, then obviously it's not a prime itself. And let's just check by running whether this also works. And it does. So that might not be a huge amount of cost savings, but if this number were a lot bigger, or if we wanted to have whatever this input number is be dynamic, then that would of course be pretty helpful. But yeah, that is it for today. I hope to see you in the next one.